Okay, welcome back to this short introductory series on Arduino Uno. So at this point we have actually gone through the Blink sketch. We've looked at how we can begin to use variables. So this is all handling outputs, and so where I want to go next is to show you how to utilize inputs as well. And so the first thing that I want to do is go in here and we're going to add a button. So if you refer to the web page, I do have a button illustration that is on the web page. You need to wire in your button with a 10K ohm resistor to ground. This way the button can drain and we can basically avoid some of those false readings utilizing a pull down resistor. And so what we're going to do is put that on pin 2. So we're going to send that voltage when it passes through the button to pin 2. So we need to set that up in our software. So the first thing I want to do is declare a variable. We're going to go ahead and say int. And actually, this is incorrect as well. Okay. So we say int button pin. Set that equal to 2. And the first thing I want to do with this is make sure that I'm reading it correctly. So we're going to go through and we're going to set up our pin mode. And we're going to set our button pin. We're going to set that as an input. Second thing I want to do is actually utilize our serial monitor. And so our serial monitor allows us to see what is going on between the Arduino and the computer. So it sets up a communication. So we're going to use a library called serial. And we have to use serial.begin. And we're going to tell it we're communicating on 9600 baud rate. So this opens up a channel between the computer and the Arduino. And for now I'm going to just delete what we had in void loop. And we're going to go ahead and send our button information back to our serial monitor. The way we do that is using serial library, serial.println, println. In parentheses, we're going to use a command called digital read. And so what digital read will do is it'll read what we put in the parentheses, which is our button pin. We close the parentheses on button pin, close the parentheses on digital read, and put in a semicolon. So it'll read if there's any signal coming in on the button pin, and it'll print it to the serial monitor. So we're going to go ahead and upload that very short sketch and see what we get off of our input. So there are two ways we can get to the serial monitor. There's this button in the top right corner. It says serial monitor when you hover over it. Or you can go to tools and come down to serial monitor on the menu. And that'll open up this second page, and you can see there's a bunch of zeros scrolling through. It's going very fast. This can read thousands of times a second. And if I touch the button, it'll start shooting out ones. So it'll give me 0 when it's reading no voltage coming in on that pin, and it'll give me ones when it's reading a 5-volt input. So as you can tell, that's pumping out a lot of information very quickly. And the way we can actually utilize this a little better would be to slow it down. So we've used the delay command before, so we're going to use it again, delay, and in parentheses, let's just say 200. And we're going to upload that one more time. And we're going to open our serial monitor. And now you can see that you're getting basically 5 readouts per second. And so that's due to that delay. And so it makes it a little bit easier to get a single one instead of 2 ones. And we're going to look at this a little bit later in our next program. So let's close this and let's use this input now. So to use this input, I'm going to need to assign a couple new variables. We're going to use a new variable type called a Boolean, which basically are true-false statements. So we're going to have Boolean, B-O-L-E-A-N. And the first one I'm going to put in, I'm going to call it state. And what this is going to do for me is it's going to track the state of the light, whether it is high or low. I'm going to initiate it with low. And the second one is going to end up being button press. And button press is going to track whether or not we have pressed the button. I'm going to initiate it with a 0. So what I want to do now is come down here and go above the delay 200. We're going to assign button press a value. And this is going to change depending on whether or not the button was pressed. And the way we're going to do that, we're going to go equals. We're going to say digital read. Oops, if I can spell it right. There we go, digital read. And we're going to tell it to read the button pin. And what that'll do is every time this loop starts over, it reads the value of the button pin, and if it's a 1, button press will become 1. If it is a 0, button press will become 0. And each time this loop is repeated, it'll keep checking that, and it'll keep reassigning the value based on what is there at the time. So next we're going to go down here. We're going to start using a conditional statement. And so conditional statements are logic statements that allow you to determine what is going to happen in the code. So the first thing I want to do is I want to check whether the button was pressed and the light bulb was off. And so what I'm going to do is use an if command. So if, in parentheses, button press, and we're going to use 2 equal signs. And what this does is it tests to see what is there. And we're going to say test to see if button press has a value of 1. Then we're going to say and, so we have to use 2 ampersand symbols for that. So this is a logic and the state. We want to test the state and see if that previous state was low, meaning that my light bulb was off. And rather than ending with a semicolon, we're going to end with an opening curly brace. So what this will do is if the button press is a 1 and the state is low, it'll execute whatever code I put in the curly braces. First thing I'm going to do is I'm going to change the state. So our state was low, so I'm going to switch my state now to high. And what I want to do is now use a digital write command. And I'm going to say LED pin. And I'm going to tell it to write state. So whatever that state is what we're going to write to this pin. So if the button was pressed and previously it was off, it's going to turn it on. And so now we're going to do the same thing for the other condition, which is the button was pressed, giving me a 1, but what happens if the state was high, the light bulb was on? Well, it's going to basically be the same command. So I'm going to just simply save some time, Control C and copy, Control V to paste, and I'm going to change this a little bit right here. We're going to say high, and here we're going to switch state to low. And so now this says if the button was pressed and the light was off, turn it on. And the second one says if the button is pressed and the state is high, we're going to turn it off. The only other little piece I need to fix here is this else if statement. So we check to see if this is true, do this. Otherwise, check this if statement and perform the operation. So let's go ahead and upload that and see if that worked. So it's compiling, checking, puts it in. And now when I press my button, my light comes on. Press it again, my light goes off. So if you press it a little bit quickly, you'll notice that it doesn't always go the way you want. Sometimes you might have to press it 2 times to get it to turn on or 2 times to get it to turn off. And what this is it goes back to what we looked at in the serial monitor. That when you press that button, sometimes you're getting multiple 1s. So you might get 2 1s in a row, and that turns it on and off so quickly that your eyes cannot see what happened. And so we'll address this in another tutorial where we look at a debounce. A debounce basically goes through and it sets up the software to check for that exact condition happening, and it corrects for that. So we're going to go into a little bit further with conditional statements, and we will debounce the button in another program. So for now, this is going to be it. Again, thanks for watching. This is going to wrap up this short introduction to the Arduino Uno, and we'll go into deeper detail in other parts of this module. Thanks again.